For question number 4, we're going to notice that we need to do correlation right here. I'll be doing something slightly different, but I want to talk first about removing outliers. To remove outliers in a data set, we need to first make a histogram. So let's go ahead and do this. Go to Analyze, Distribution, and we need to select age of first rank for your question. So this is for your question, you'll be selecting age of first rank, and if you notice there's these people up here that are 999. Also in my data set, I have someone who's 999. So right here, I can see that there was a person up here that just barely visible. If you notice as you watch my selected, let's watch very closely on the selected. I have one selected now I have a whole bunch, and I scroll down and I catch that extra person who put in 99. So I'm going to remove all these people by going to rows, exclude, rows, hide. So now they're removed from the data set, and I want to go to script, and I want to go to redo analysis just to check it. I have some people who said they started drinking down here at age 0. I want to select them again. So if you notice, I am now selecting 2 people who said they started drinking at age 0. I think that's preposterous. And I did the same process. Go to Analyze just to look at the data set again. Redo analysis. And now we have our final one. So going over, I removed outliers. This is for your assignment right here. I'm going to do something slightly different when I do correlation. But I have now removed the outliers. If you notice, this was before the 999 and 99 were removed. Then I removed the zeros, and then I have my final one right here. So my data would now be ready because I have those weird observations removed. But let's do something slightly different, so I'm not doing the exact same thing as you. I'm going to go to rows, clear row states. You will not do this because you want those people removed at this point. But I am doing something different. I'm going to analyze the relationship between height and weight. Before you do the analysis, what relationship do you expect to see? Well, I expect a strong linear association between height and weight. As height increases, I expect weight to increase. Strong linear association. So the next part says that I will have to remove people who are the 999s, and you will have done that in the first part, so you've already done that, removing your people. And there's also a person who's a 99. Make sure you remove them too. Produce the coefficient and the scatter plot for the correlation coefficient and the scatter plot for this. So let's go ahead and do that. I am doing something slightly different. I'm going to go to Analyze, Multivariate Methods, and you'll go to the same spot right here because it says Correlations. So let's click it. And I am doing height and weight. I'm going to click both of them. You will not do height and weight. You will do what your question says. When I click this right here, it'll give me the scatter plot. Now to get the correlation, I am going to go to Pairwise Correlations. And at this point, I can take a screenshot. Go ahead and take a screenshot right here with Snipping Tool or Command-Shift-4. I'm going to actually move this up a tiny bit. This is going slightly outside the window. So let's see right here. I want the full screenshot. It's hard to get everything just into view. I'm going to have to change the size on this. There we go. So now I have everything I want in here. Nice screenshot. There we go. So in this screenshot, I have the correlations, and so the value of correlation is right here, 66.14% or 0.6614. Should be stated as 0.6614 because it's positive. And we have down here, we have correlation again, and we have the significance level. With that in mind, we have the first part done here. We have created the scatter plot, and we have the correlation, which is 0.6614. Strong, positive, linear correlation. Next, we need to remove odd values. So if we have any odd values, we need to remove them using the exclude hide. We need to use our judgment here. I always say do this process. Even if you don't say anything too odd, you can take out things that don't follow the trend, just some things that are kind of really odd. We wouldn't always just remove things like this in statistics for no reason, but it's just to show you how to remove things and then redo it. Now remember, I've already taken a screenshot of this. So when I do this, it'll change the output. I'm going to go up here to rows, exclude, rows, hide. And it helps that we have this. It's also rows is back here. You might have to click back here if you don't have it in this window. Consult question 1 if you don't have rows up here at the top, how to get rows up there at the top. With this in mind, we have now removed those points, but we have not redone the analysis. When I go back here to script and redo analysis, you will now see that my correlation has changed. My correlation has increased from 0.6614 to 0.7318. So I would then need to take a new screenshot of this new correlation right here. Take a new screenshot. There we go. I also have the significance down here at the bottom. And we can talk about these things. We can talk about what's significant, what's not significant. Let's look at the next few questions right here. Using the revised data set, list and comment on whether the conditions for correlation are satisfied. Now, the conditions for correlation are quantitative, straight enough, and no outliers. So we've definitely met those conditions right here. You need to list them out individually and then describe if they are met. That's very important. So is the correlation significant at the 5% level? We need to look over here, and yes, we definitely have significant correlation. And you'll notice right here, we have a confidence interval telling us we are 95% confident that the true correlation between these variables is contained in the interval 0.6913 to 0.7677. 0 is not in this interval. We are saying we are 95% confident that the true correlation is not 0. So yes, we have significant correlation because correlation, we're pretty confident, is not equal to 0. And our p-value is below 0.05. Remember, a two-tailed test is the same as doing a test for significance. Or excuse me, a two-tailed confidence interval, or a two-tailed test is the same as running a confidence interval. A two-tailed test is the same as running a confidence interval. That's a great concept to remember right there. And we see significance on the test because we see zeros not in the confidence interval. Going back here, finally, we need to make sure we clear the row states. Let's go back into our data set here and go to rows, clear row states, and if you notice, everything has been cleared. I have my screenshots. I've put them into my Word document. They look nice and neat, and you have done the fourth question. Good job.